Okay, so before we get started kind of going over the regression project, are there any questions on chapter 3?
Do you remember that last problem?
The last one?
I don't know why. I may be like overthinking it, but
I couldn't figure it out either.
Okay.
I did the exact same thing. Follow the exact steps.
y'all write the homework.
Yeah.
Let's take a look.
I don't know how. I mean, I guess that's exactly what we're going to be doing too.
So number 7, 3.17.
Yeah.
Okay. So, okay, so that one you're doing the high-low, right? So you just chose the scatter graph.
Yeah.
And then, okay. So then after you do the scatter graph, or are you having problems coming up with the cost function?
Yeah.
Okay. Okay. So obviously my numbers are different, but you should be able to use this data and do your high-low to solve for like the variable cost per unit. Is that where y'all were starting out?
Mm-hmm.
Okay, so remember when you're doing high-low, make sure you take your cost at your highest activity level. So first I'd want to look for my highest and lowest month of activity. So again, I know it's hard to have different numbers, but we can look. But yeah, August for me is my highest activity level. So my cost was $195,510.
Yeah, you said always go off the activity level, not the cost.
Yes, yeah, and that's an easy one to mess up on because we look at costs and not. So yeah, make sure you're going off of your activity. So I'm choosing my month at my highest activity. And then look for your lowest activity, which mine is February. 135.60.
That's what I did. I took the high and low total cost.
Okay.
Well, that last
Yeah.
one, it switched them from the ones that we practiced on.
So you're like, oh,
It did the
then
total
it had the
cost
total cost
and then
first.
So I just
Yeah.
immediately went to the last one.
Right? You're like, that's what we did. Is that what you did too? Like, did you go off of costs maybe and not like activity level?
I tried it every once in a while. It seems like.
Right? Yeah, because you'll want to look for your month at your highest activity. So for mine, it was August. And so I took my cost at my
Mine's
highest.
exact same as yours.
Is it? Maybe do we all have the same data actually on that one? That may not be algorithmic actually.
Looks like.
Yep, you're right. That one, we should all have the same numbers. So that makes it even easier. Yay. So yeah, I took my cost at my high, my 195,510, minus the low of 135,060. And then 4,100 minus 2,600. So staying in the August, February. And then, oh, I hate it when computer does that. Should get 60. $1,500, right? Sure. Did you get variable cost of 40.3?
Mm-hmm.
That's right, isn't it? Yeah. So when I solve that, I should get my variable cost per unit of $40.30. Which does match the cost function there. Does that make sense?
Fixed cost was 30.
The variable cost per unit.
Oh,
Yeah, the variable cost per unit is $40.30. So yeah, I use this I use the high-low method, and I get my variable cost per unit. And then to solve for my fixed costs, I would use one of either my high or my low data. Okay, so I'll use my high. So I would say my total cost of $195,510 minus 4,100 times that $40.30.
Shouldn't it be the one that,
Right?
Oh, yeah, I remember.
Okay, I'm like, right?
Well, I wrote it specifically formula based, so I put the 195,510 equals. question.
Okay, yeah, you did it as an algebraic function. Right? Coffee is always good. I've had a coffee and like maybe 2 Coke Zeros today. I don't remember. I lost track. And then we subtract, and so we should get fixed of 30 to 80. That high-low method trips people up, I think, because we obviously our eyes go to total cost, but you always want to base it on your levels of activity.
Yeah, I couldn't compute the cost formula. I think that's why I was just like.
Yeah. Right? Like it's just so easy. You're like, cost. Yeah, it's a common error. It's easy to get confused.
195,510, where'd you get that?
I got that, so up at the top, yeah, so like based on August, right? So August was my highest level of tests at 4,100. So I took my cost at my highest level of activity minus my cost at my lowest level of activity divided by my highest level of activity minus my lowest level of activity. So yes, that one can get tricky, especially when they do put them in a different order. So does that make sense? Everyone better on that one? Okay. And then once you get that cost function, you can do number 2, where you're just plugging in for 3,500 tests. Okay. Any other questions on chapter 3? That was the trippy one. Okay, sweet. Where am I at? So down here. So let's talk about our project. So if you scroll down on Canvas, down after all that, it's after Unit 1. So there you should see a section titled Project. And there's a lot of stuff out here, but I'll tell you what you need. So today we are going to run a practice regression, and that will help you on your regression project, okay? So when you do the regression project, which is what we'll be working on this week, it'll be kind of similar to what we do in class. You'll just be analyzing it a little bit further, and you get to do another high-low, yay! Which is good though, it's good practice. So, and it's kind of cool too, because you'll be comparing your high-low data to your regression data to kind of see how different it is. You know, when we talked about the high-low method, it is an estimate. And so when you compare it to a regression model, which actually gives you a more refined estimate, you can see how different the costs are. So you could kind of see how off our estimates could be if we're not choosing a good method. So that's kind of the purpose. Running a regression is actually pretty simple. You just have to know what inputs to put in. And once you run it though, you'll get data. And again, you just have to know what data is important to us. And the good news is we are not statistical analysts. So you do not have to, read into every little number, but we're going to focus on just like basically, we're going to return our variable cost per unit and our fixed costs. So we're going to get those returns just like we do using a high-low method, although it's quicker and the computer's more accurate than we are, which is also lovely, right? Unless you run the computer, tell the computer to do it wrong. And then there's just a couple other little numbers we look at. The good thing about a regression is not only does it run all the data for us, it also tells us how accurate our cost driver is. So like in this, I don't have it up there anymore. Like on that homework problem, I already took it down. That was smart. Close this real quick. On the homework problem where we had, you know, the number of radiology tests, if we ran it as a regression, the regression would tell us how much of a percentage it was that that the radiology tests, the number of tests, actually were a cost driver for total cost. So it actually gives us some more data to support whether we are choosing correct cost drivers, because it is kind of a guessing game, right? We're saying, oh, our total costs are driven by how many radiology tests we do. Well, there could be some other cost or some other cost driver out there. And when we run regressions, we can kind of narrow that down and actually find cost drivers. So with high-low method, we can't, right? We're just estimating. So regressions give us a little more accuracy in the data that we're using. So on the project, we'll do the practice regression first, and then we'll talk about the project itself. So go ahead and open up. If you click on practice regression, go ahead and click on that. That'll load you into Cengage. So we'll want to do that. So practice regression. And also, I'm going to go back to my home page here. In that same project unit there, click on the one that says practiceregression.xlsx. That's the Excel file. So I went ahead and put the data for the practice into an Excel file for us. So go ahead and download the practice regression Excel file as well, which you'll notice is similar to that last homework actually. Okay, move that down. Okay, so this, I just put this in for us. I typed this up. That way we wouldn't have to do it. So this is the same data that's in Cengage. So go ahead and when you're in Excel, make sure you click Enable Editing so you'll be able to run.
So we want to download this?
Yes, yeah, download that Excel file and then open it up and click Enable Edit. Okay. So this is the data that they gave us. I copied and pasted it from Cengage. So let me go back into my Cengage real quick just to go over it. Okay. So again, I took this data that they gave us in the problem, which as you'll notice is actually the same data as what we just ran the high-low on, which is kind of cool because we can then actually kind of compare what we get. Says Deepa Dalal opened a freestanding radiology clinic. She had anticipated the costs for radiology tests would be primarily fixed, but she found that costs increased with the number of tests performed. Costs for the service over the past 9 months are as follows. So we have January through September, both the cost driver, which in this case she thinks is radiology tests, the number of tests we perform, and then our total cost. So it says compute the cost formula for radiology services using the method of least squares. Well, method of least squares is just another name for a regression. Okay, so we're going to run a regression, and we want to answer just like what we did here. We want the same thing. We want to know our fixed costs and we want to know our variable costs per unit. Okay, so again, if you go back into that Excel data, here's all the data. We are going to run a regression and solve for fixed costs and variable costs per unit. Okay, so the first thing we have to do before we can run a regression is make sure that we have the add-on tool in Excel installed and ready to go. So along the top here, you're going to click on the Data tab, and I have instructions on Canvas, so when you're at home, you can redo this. I'm going to click on the Data tab. Okay, and like you can tell, like if we had a regression, we would have a data analysis tool over here on the right. Okay, so we don't, or I don't think anyone does because they redo it every semester. But that's good because then we can step through it so you'll be able to do it at home. I'm just going to click Got It because we don't want that. So basically what we're missing is a data analytics tab over here. So what we're going to do is we're going to click on File, and go all the way down in the green bar to Options. So File, Options. Okay. And then over here in the left, click Add-ins. Click on Add-ins in the left. Okay. I need to move this. It's always in my way. At the bottom, it says like Manage Excel Add-ins. Click the Go button next to that. So at the very bottom, where it says Manage Excel Add-ins, click Go. And the one we want is that very top one. So just choose Analysis Toolpack, put a little check mark by it in that box. So put a little box or check Analysis Toolpack and click OK. Bless you. So now I was still on that data tab, my data tab on my ribbon. Notice I now have a new box over there that says Analysis Data Analysis. So that's all you have to do to add that data analysis tool pack to your Excel, and that should work on 2016 or 2019 or 365. It's the same, thankfully. And again, I have instructions on running a regression, but I think it's just easier to show you quicker. So now that we have that, what we can do is we can take this data that we have in this Excel spreadsheet and like run a regression. So once you have that pop up, just click on Data Analysis. And you should have a dialog box pop up. And I'm going to scroll down, they're in alphabetical order, and look for regression. So I'm going to click on regression and then click OK. What I want to do is I want to input my total costs and my cost driver and then have it run a regression on that data. So in the Y, where it says input Y range is always your total costs. So you can actually click, when I'm in this dialog box, I can click the little arrow next to that dialog or that open box. And then I'm going to click and drag and select C1 through C10. C1 through C10. Okay. So I've chosen my total costs with the label. So total costs, C1 through C10. And then I can click back the little down arrow and it takes me back in to my full dialog box. Your X range is going to be your variable cost, or your cost driver, sorry, your cost driver. So I'm going to click the little up arrow next to X range. And as you can imagine, I'm going to choose B1 through B10. So my X range input is my cost driver, B1 through B10. And then I hit my little down arrow. I chose labels. That way when we get our regression data, we'll have labels in the results. So make sure you put a little check mark in the labels box. So I'm going to check next to labels. And then the last thing we do is we just want to tell where we want to see this regression data. Well, I like to see it right here with my regression, you know, with the actual data. So I'm going to click next to output range. And I'm going to click my little up arrow there. And I'm going to say A12. I'm just going to click in the cell A12. That's where it's going to spit out my results. And then I click my down arrow. So A12. And then just click OK. So it didn't take us very long, and we're new to this, and we just ran regression data on this problem. So if I scroll down, I want to show you a few things. If you scroll all the way down, like mine A28 says intercept, and then right below it, it actually says radiology tests, okay? These are the two numbers I'm concerned with the most. So when we did the high-low, we returned a fixed cost at $30,280 and a variable cost per unit of $40.30. Well, now we're getting different results here. These are the results, okay? The intercept, where it says intercept, that's my fixed cost, okay? So when I'm writing my cost function, under my high-low, I'm gonna write that one just so we can compare the two. We had total cost equals a fixed of $30,280 plus $40.30 times however many number of tests, okay? Well, now my new cost function, they're telling me my total cost is $36,588.82. I think in Cengage I'll have us round, but I'm going to round to 2 decimals for now. So 36,588.82 plus cost per radiology test, $39.48. Okay. So when I do the right inputs, when I tell it my total costs and I tell it my cost driver information, it returns the same type of stuff I did by having to do all this high-low method calculation. It's different though, right?
Yeah.
We get different data. Well, that's because, again, we're looking at, a regression that's using computer models and statistical analysis. It can do things we can't do with simple math on the board. So again, I don't expect you to understand all of this, but what is kind of important to understand is we look at 2 things. We look at, how did this stuff here? Well, we really can look at 3. But we're going to look at, let's see, the multiple R here. Okay. So basically what that means, the closer that is to 1, the more chance there is that there's a relationship between the cost driver and total costs, both for multiple R and R squared. R squared is just more important when we run like a multiple regression. But basically, there's a 0.87 or 88% chance that, well, not really 88, but just closer to 1, that those are related. So the multiple R, if it's close to 1, if it's a positive number, it can be anywhere from a +1 to a -1. So the closer it is to a +1, the higher their chances that number of radiology tests is actually driving our total costs. So we look at that, and that gives us an indication of whether it's a cost driver. Well, it's pretty high, so there's a pretty good relationship there. The other thing we look at is the adjusted R squared, which is kind of cut off, but it's adjusted R squared. That's the percent of relationship. So there's a 73% relationship between number of radiology tests and total costs. So that's a pretty decent amount. There may be some other cost drivers there, but that's a pretty good indication that number of radiology tests is driving the total costs. The standard error here is kind of high, 11,236. The higher that number is, the worse it is, really. We want a lower error number because that means there's lower chance for errors in our data. Okay. When we're looking at regression data, again, we won't go into the whole, an observation is just how many it ran. It ran 9 months worth of data. Okay. Well, the more months of data we have, you'll probably see a lower standard error rate because we have more data to compile. With only 9 months worth, there's a higher chance of error. We could have outliers, which the book kind of talked about and we saw in the scatter graph thing. If we have a month where maybe our radiology equipment was broken for 5 days, that month's worth of data may not really be accurate. And so it kind of throws off our regression analysis. Okay, so that's one thing that can happen. So any month where, or maybe we had a new radiology tech and they didn't know what they were doing and we had to retest like 8 people, that could cause problems too in our data. So there's reasons why, we may have a high error rate, or there's reasons why we may have data that has outliers that just doesn't fit. When we looked at it on a scatter graph in your homework, if it wasn't on that linear, if it was, kind of a weird number that was outside of the line, that's where that comes into play. Okay. So again, it's pretty easy to run a regression. You just have to know where it is and what inputs to use. But then you immediately are able to write a cost function. It's kind of cool, right? I mean, you do that and you have a cost function. And you know, if you do it all the time, obviously it gets pretty easy. Again, there's a lot more data here that we will not look at. That's for the statisticians. So we will not go into that. You can read about it. You know, if you Google regression analysis, it'll tell you more about what all of those mean. But in this class, we're really just concerned with this stuff up here, and then our intercept and radiology tests are a variable cost per unit. Any questions on that?
I'm wondering how, ultimately this is teaching us where we can go in and do our regression project. How do we get the data from Canvas onto the Excel?
Good question. So I will show you, kind of like what we just did. So I have, for your regression project, you'll have a Canvas, or sorry, a Cengage assignment, just like we're going to input. Yeah. And then you'll also have another Excel file that I created for you to run your regression. And then once you've completed, in Cengage, you'll submit, just like you always do, of course. And then when you've done like this on our practice regression, you'll want to save your Excel file, and there'll be an assignment link on Canvas for you to upload that, so I can look at it. And really, I just look to make sure if you get it right in Cengage, then you've ran your regression right. But I just look to see what you did. Good question. So yes, let's finish this in Cengage, and then yeah, we'll open up the project. It is a little more in depth, so I'll talk a little bit about that because it's just a little different. I don't think this one has it. Yeah, it doesn't. They didn't give me enough to practice with. So on number one, it just said compute the cost formula. Well, we have that right here. And let's see, it said if required, round your answers to 2 decimal places. Well, we did. So I can just type that in. So total cost equals 36,588.82 plus 39.48 per unit. I check it, it makes it all wonky, but. So then on number 2, we're just using that formula like we have with past formulas to figure out what our costs would be if we had 3,500 appointments. Okay, so in October we had 3,500 tests. We're just going to plug in 3,500. So it'd be the 36,588.82 plus 39.48 times 3,500. Okay, so we're just using that cost function. So if we ran a total of 3,500 tests, radiology tests in October, what would my total cost in October be?
141,768.82.
141,768.82. Thank you. Oh, round to the nearest dollar. That's why I'm like, why?
I got something different.
Did you? Okay. Okay, yeah, that one.
I got 174,769.
I forgot to bring my answer, so I'm like, I don't really know. So 174,769. You will take, yeah, 39.48 times 3,500. Oh, you just had the wrong, yeah. Yeah. Because this should be what, 138, 180. Yeah, there we go. Okay. So any questions on that one? Okay, so that's just what we call a simple regression. We're only analyzing one cost data driver. Okay,
So that's the practice. Again, let me close out of that.
Do we need to save this Excel?
You can if you want to, just for your own purpose, but you don't have to. Yeah, for that one, since it's just the practice. So for the regression project itself, I put everything under it too, but if you click on regression project, okay. So I put out instructions for running a regression in Excel. So that has all the instructions we just went over, you know, how to add that data analytics tool, how to choose your total costs and your cost driver and all of that. And then I'm recording today too, so if you prefer to just go back and watch, you know, to do it at home, you can do that too. So for your regression project, I do give you an Excel file right here. Within, if you click on regression project, you'll have that Excel file. So I'm going to go ahead and open it up just to show you. And like I said, the project's just a little more in depth. So there's two different tabs because there's two different questions on your homework, on your project. So as you can see, we have a simple one, the PR 3.35 is just machine hours, and then we have total cost or power cost there, and that's 8 quarters worth of data. And then you have the second tab down at the bottom. Notice here you have 20 months worth of data, and you have 3 cost drivers. Okay, good times, right?
Oh, it's 2 different tabs.
Yes, yes. So you're going to have 2 different tabs.
It's going to be a multiple regression.
It is, yeah. On this one, we're going to run a multiple regression. So just while we're here and talking about it, number 3 has where you go into Cengage to get, you know, what you're supposed to be doing. And then number 4 here, you'll notice that regression project Excel file. That's where you'll submit once you've made all your changes to your Excel file. So I'm going to open up. So you'll kind of see, like I said, it's just a little more in depth. They didn't give me a lot of options for doing more in class. So let me see. The second one, number 2, I actually put them out of order probably. The second one, as you can see, the second one is less data. So here you're doing one very similar to that last homework problem. You have the scatter graph to look at. You have all the data. You're doing high-low. So you'll do your high-low again, just on one cost driver. So you'll do all of that. And then on number 3, it'll have you run a regression. And then it asks you, like, for the adjusted R2. So we kind of talked about that. And then on number 4, it has you rerun the regression, dropping a point as an outlier. So I just wanted to show you really quickly what I'm talking about there. Okay, so that's on this PR 3.35. Okay, so once you've done your high-low on that one, you'll come in and run a regression on this data using this as your Y, the power cost as your Y, and machine hours as your X input. So you'll run your regression. So you'll do that, and I don't care if you save it like as a new tab or you save it in this, whatever is easier for you. Then it'll ask you, it says that this number 1, the 20,000 hours with the total cost of 26,000. What they're talking about again with an outlier is they're saying that month of data doesn't follow our linear scatter graph. You know, it's an outlier. So it's not good data basically, for whatever reason. We've determined that that month of data is not good. So after you've ran your first regression, what you can do to run the second regression easily, if you just right click on row 2 and delete it, it goes away. And then you can rerun your regression, again, using Y and X. So you'll just have 1 month less of data, okay? That's probably the easiest way to do it. Just delete it out and then rerun it. You'll already have your original data from your original regression, but you'll be able to see how removing that outlier changes your data and makes it more accurate. Okay, so that's kind of the difference on that one. Any questions on that? Okay, Then on this really long fed one, as you can see, when I go into Cengage, it's the first one, number 1. It says DeMarco Company is developing a cost formula for its packing activity. A discussion with the workers has revealed that packing costs are associated with the number of customer orders, the size of the orders, and the relative fragility of the items, okay? Because it takes more time to wrap up those fragile items. So they're giving us total cost here, and then we have number of orders, weight of orders, and number of fragile items. So they're saying they think all 3 of these are cost drivers. So then we have to run what we call a multiple regression. And we did that. We didn't run a multiple regression, but we looked at an expanded cost function before.
Yeah, I'm trying to get it to do it now, and it's telling me input range contains no numeric data.
Okay, I'm going to show you how to run a multiple because it is just a little different. So on part 1, it'll have you just run a single regression with just number of orders. So in that first one, you'll run a single regression just like we did together. But then on number 2, I want you to use all 3, the number of orders, the weight of orders, and the number of fragile items. So when you get to that one, you're on PR 3.36. You know, I'm going to go back to my data tab and click on data analysis. And it should remember a regression for you. So you should be able to click OK. And notice it kept my old data, which is incorrect. Okay, so I just want to choose my new Y range. So I'm going to click that arrow again. And in this case, they gave me my total cost first. You know, they love to put everything in different order, right? So I'm going to choose B1 through B21. B1 through B21.
21.
Uh-huh.
That's 20.
Through B21, row 21. Yeah. And then for my X range, when I'm running a multiple regression, I need to select all 3 columns. Okay, so I'm actually going to choose C1 through E21. C1 through E21. So to do a multiple regression,
So on that first one you did,
select all of them.
B.
B1 through B21. Yeah. Yeah, your X input should be, or I'm sorry, your Y input, your total cost input should be B1 through B21. And then when you're doing your X range, you want to select C1 through E21. So you want all 3 of those columns. And then just make sure your labels is chosen and change your output range. Because if I put it in A12, it's going to output it right here over my existing data. So, you know, because I ran this regression already. So I'm going to click there and, you know, I'm just going to put it over here like G9. You can put it wherever you want. It doesn't matter. You can put it on a new worksheet. So Y range, B1 through B21, X range, C1 through E21. Labels are chosen. I updated my output. And then now I get all of my regression data. So you'll be able to put this in to Cengage what you return. And as you can see, like, it looks like from the data we're returning that there's a high correlation between all 3 of these cost drivers and total cost.
Okay.
So
it's asking for the adjusted R square. Now, which one is that going to be on here? Because we've got an R square and then we've got an adjusted square.
yeah, you'll want to choose your adjusted R square. So yeah, when they ask, so let's see. Yeah, they ask for adjusted R square. Yeah, so that's the one you'll want is that adjusted R. So in this one, it's 0.99989. So very high. Again, you'll compare this. I didn't run the single regression, but you could have ran, you know, you'd also be running a single regression and comparing. So you'll look at this. Notice our standard error is way down from our one we did previously. So there's less chance of error in this. And then what you're looking at down here is you're able to write your cost function off of now your intercept here is still your fixed cost. So total cost equals intercept fixed cost of $474.72 plus $2.10 times the number of orders plus 0.74 times the weight of the orders plus $2.31 times the number of fragile items. So we're just expanding that cost function to include 3 different cost drivers. Okay. So you'll have a much longer cost function. But again, kind of the purpose of this is to be able to look at and see, you know, you could run a regression with just number of orders, which you'll do. You could run it with number of orders and weight of orders. You could run it all multitude of ways. And then you would look at your R squared and adjusted R squared and pick the highest one, the closest to 1. You know, in this case, I don't think you can get much closer to 1. So, you know, this is probably our best
Is that
estimate.
the right information ran, or is that the sole project?
Yeah, I actually ran the,
Because I'm coming up with, I mean, it's got a different summary output than that. The figures are different, and I tried putting them in, and it's not taking them.
like on Cengage. Make sure you're on the multiple regression one though, because like number 2, because number 1 is doing a single.
Okay, I see.
Yeah, that's probably what it is, because I didn't do the single regression.
Oh, I see. I got you.
Okay. So, any questions? I know.
Really that easy when I go home too.
Right. I know. So I was just gonna say, I know it looks easy, right? But again, I did record, so you can go back. I'll post the video tomorrow, probably once I get it uploaded to YouTube and everything. So hopefully you can just kind of recreate, as long as you get that data analytics tool on there, and just make sure you're choosing your right Y and X input. Hopefully that it'll go smoothly. Oh, yeah, let me show you. So I usually just post them with the chapter. So I'll be posting, I think I have one from last semester out there already that I'll probably replace. Like, yeah, I do. So I'll replace that with tonight's. But yeah, if you're in the unit, for example, we had chapter 3, I usually post it like after the practice. So yeah, I try to remember to post those out there. So that way, if you want to review them or if you miss class, you have access to them. Since I just see you guys once a week, right? Makes it a little more difficult. But yeah, hopefully you'll kind of have fun, you know, like looking at the data and comparing it. I mean, that's something I enjoy, but I know not everybody does. But I think it's good as an accounting student, though, just to look a little further and do more analysis and get kind of a different perspective of accounting. It, you know, not just running numbers and statements, but being able to look and understand and analyze data. They're really moving towards more of that, and I know Megan kind of tests, and she's been through my financial accounting. We're adding more data analytics into those courses that I just did last semester. And well, both financial and managerial, since you dualed them up. Well, Cassie too, you got to do it too, that's right. Like, yeah, you were in my managerial. I forgot I did it in managerial. We were such a small class. So yeah, it's really kind of cool, and just being able to look at real data and understand. I feel like it gives you a more real world feel for what we're doing. You know, why is this important? Well, they do regressions in companies. You know, they run this data, and so being able to say, oh, well, I've ran regressions and I kind of understand some of the output or how to read it is a big thing. You know, understanding data analytics. So
I have a question then.
Sure.
I'm not understanding how the multiple, the method of least squares works on the regression. What's the difference between that and the multiple? I mean, are we using the data from 3.35 for the single one?
Oh, no, you'll use that same data for the single one. So the only difference is
3.36.
like, Yeah, on 3.36, I ran it the multiple one, but you'll run one where you just choose number of orders as your X data. So you'll run 2 regressions.
So it's gonna be the number of fragmented items and or the cost and the number of orders.
The cost and the number of orders. Yeah, because they said, let me go back in. Yes, run a regression using number of orders. So yeah, you'll always use total costs. And so on that number 1, you'll run a single regression with just total cost and number of orders. And that's just to kind of see, because you're going to get less accurate data. So you'll be able to compare that and look at it. Any other questions?